Yes, welcome back everyone, Homemade Madness, and this is Homemade Massive DIY CNC Build Part 4. So in case you're new here, I'm building a huge DIY CNC machine, and in Part 1 I made this massive steel frame, then filled it with concrete to make it even heavier. Part 2 I built this gantry, which can ride on the frame, and on there it has the X-axis and the Z-axis for the up and down movement. Part 3 added the ball screws, servo motors and got it moving. And in this part 4 I'm going to do all the electrical work needed to get it moving on its own and make the first test cuts. So that means making an electrical box with all the components in there, connecting them to a CNC controller, which is the MASSO CNC controller, and I'll show you some more of it later of course. Then do some wiring, figure out how to set up this controller and make some first test cuts. And that of course also means I have to install this huge spindle, which basically is the motor to do the actual cutting. And once that's all done and working, I'm gonna make an automatic tool changing system so the machine can switch between cutting tools all automatically. It's gonna be pretty cool. And finally I'll make the flood coolant system, and once that's done we are gonna cut some steel with this machine. So a lot of work to do and also a lot of explaining to do, which I'll do during the video. So for now, let's get started. Okay, so time to start work on the actual electrical for this thing. So I bought this electrical box, haven't mounted the door yet for easier access. But before even starting with the electrical, I already know this box is probably a bit too small, because this is all the stuff that will need to go in here. 4 2 kilowatt servo drivers to drive the servos. The 9 kilowatt spindle VFD, which allows us to alter the RPM of the spindle. Of course, the MASSO CNC controller breakout board with cables which will go to the actual controller touchscreen. But I'll talk some more about this controller later on. Then the MASSO relay module and a 24-volt power supply. And then of course hundreds of wires, signal wires going to the servo drivers, inputs going to the control board, outputs going to stuff like coolant pumps and other relays. And to give myself a fighting chance at managing all of these wires, I got some of this cable raceway. And with the cover on there, hopefully after I'm finished it will look kind of neat. So electrical isn't my strongest point, nor my hobby, but I'll try my best to keep it as organized as possible. And then some din rail to mount the controller and the distribution blocks. So it's definitely gonna be a bit cramped in here with all this stuff. But I think I found a way to fit everything in here pretty nicely and still have some room left over for the cable raceway and stuff. So let's get it mounted. So starting off with the servo drivers, and everything will be mounted with these self-tapping screws. And then the spindle VFD will fit nicely in here. The cable raceway can go here. And then the din rail in between there, to which the MASSO controller can mount. And then some power distribution blocks for both 24 volts and 3-phase power. Okay, so this is where we left the frame in the previous build part. A lot of quite messy looking wiring, and also oil lines, pneumatic lines, coolant lines, all kind of stuff. But also a lot of wires like signal wires, homing switch wires, the spindle power, of course the servo motor and encoder wires. So basically next job is to connect all of this to the control box, and then later we can connect the control box to the MASSO, and we should be able to move stuff around. So of course before we connect everything we need to know the final location of the control box, and I want to mount it under the machine on the other side, because that's going to be the main access side of the machine. So this is kind of the place I had in mind to mount it later on, and that will be fine for later on, but for now, you know, this is not really a comfortable spot to do all of the wiring, let alone having to film it. So what I'm going to do instead is mount it around here for now, temporary, and then I can measure the length the wires would need to go from this point underneath the frame to the final location point of the box. And then I can just make all the wires that length and mount them in the control box here, which is much easier. And then later on, once everything is mounted, I can slide it under the frame and mount it in its final position. So that's the plan. Let's do some wiring. So starting off with the servo power wires, of course going to the servo drivers. And at this point I still had the illusion that everything would fit in these cable raceways. But as you'll see later, I ended up routing these out of the side of the box. And then the 3-phase power, 400 volts between the phases and 230 volts between the phase and neutral. And the drivers themselves actually only require single phase power, so we ended up giving every axis its own phase of power to kind of distribute the power over all the phases. And that will prevent tripping the breaker when all servo motors have to accelerate simultaneously. Okay, so that's mostly the AC power done. All the servo drivers now have a phase and a neutral. And I also already connected up the 24 volts power supply for the MASSO controller. And next up I want to connect the MASSO to the servo drivers with a signal wire, basically telling the drivers how fast to move the motors and in which direction. And they gave me this connector with it to which you can solder your wires. But that turns out to be pretty much impossible to do. It's just way too small. But in the end I did manage to solder some wires to there. But the soldering connections are pretty weak and brittle, and I'm sure at some point they will fail. So that's kind of a problem, and I only need 5 of these 100 input pins anyways. So what I'm going to do instead is I found this wire which has 4 solid copper wires in there. And these wires perfectly fit in the holes of the connection. So what I'm going to do is just put these wires directly into the connector and probably put like a bit of hot glue on there to keep them in place. I think that should work fine, and it's definitely a lot easier. So let's do it. So now to connect the signal wires to the MASSO breakout board, and that's actually really easy because it literally says on the breakout board which axis it is and which wire should connect to where. So now to lengthen the servo power wires, and some of you may already see a bit of a mistake here. Oh man, forgot to put heat shrink on there. That is just classic soldering mistake. Okay, so quite a lot of soldering later, I now connected all the motor and encoder wires. I had to shorten the ones going on the y-axis here, and then use the cable that I have left from those motors to extend the ones going to the x and z axis, which was quite a lot of soldering, and I should have just bought longer cables. And also I chose to route the cables for the motors out of the side here instead of out of the bottom like I had before, because they're just so bulky and would take up too much space in here. Anyways, it's all connected now, and it's not really neat yet, but I think I can still fix that. Anyways, for now, let's plug it in, see what happens. Okay, so the 4 servo drivers are turning on. These 2 are saying ready, which means they are ready. And these 2 give an error, but that makes sense because I haven't connected the motors to these 2 yet. And I also see this green light turning on the MASSO controller, so I think we're good. Okay, so everything seems to be working and the light is still on, which is a good sign. So now it's time for a part I've been pretty excited about, which is trying out this MASSO controller. So I got this quite fancy monitor wall mount, and I'm gonna mount it here and then put the MASSO touchscreen on there, plug in these 2 wires, which should be enough to make it work, and then we're gonna see what this MASSO controller is all about. And I think I should also mention that I don't really know what I'm doing with all this CNC stuff, especially considering this is the first CNC router I've ever built. But you know what they say, if you really want to learn a new skill, you just gotta get yourself in so deep that there's only one way out, and that is to learn the skill. And that's kind of what I'm doing right now. And as you'll see later on, well, it worked. Okay, so the controller seems to work. I just plugged it in and it lit up, so I think it's good. Now it didn't really work first try. I first had to put a little coin cell battery in here, and I had to load the newest software onto it with a USB drive, but for the rest of it seems to work. So at this point I think I should say that MASSO sent me this controller for free, which I'm very grateful for. But the thing is, they didn't reach out to me, I reached out to them to see if they wanted to help me with this project. Because before I even started building this, I already knew I wanted this controller on this machine, no matter what. So there's a couple of reasons I wanted this MASSO controller on this machine. First of all, it's just nice to not need a computer or a laptop. Just have this one nice big touchscreen, and with only 2 wires coming out of there, it's really clean. But there's a second and frankly more important reason, and that is that this controller should be really easy to use and set up. So I guess in a minute I'm gonna find out if that's actually true. So when you're talking about CNC control software, there's a lot of choices out there. First and foremost we have Mach 3, which is by far the most used program. I use it on my homemade CNC plasma table and my homemade CNC tube notcher. And Mach 3 is very cheap, and there's a lot of info to find on the internet about setting it up. But the problem is it's very old. It's actually more than 25 years old, and you can see that when you're looking at the screen. But still, Mach 3 is pretty easy. For things like a CNC plasma cutter, it's perfect. But when you're doing a project like this with stuff like automatic tool changers and cooling systems, that kind of stuff is just really tricky to set up, and honestly I don't want to run a 25-year-old program on a new machine. So then you have Mach 4, which is basically just a newer version, and I put that on my CNC lathe. And although it looks a lot newer, and it is, I still don't really like it. And then there's just many more brands like Linux CNC, Adding CNC, Centroid Acorn and a lot more. And I guess all of them have their benefits, but still I chose the MASSO. It's the only one with a built-in touchscreen. So then the biggest strength of the MASSO being pretty easy to set up, it's also its biggest weakness. Because what makes it so easy to set up is just that you have less things to choose from, which you probably won't need anyways. And that just means there's less choices and less settings and everything is a lot easier. The downside of that of course is you don't have those functions should you need them. But as far as I can tell, for a machine like this, which is relatively simple, this should be just fine. You can also add 1 or 2 more extra rotating axes. And of course the automatic tool changer and then some other features like moving a dust hood up and down or spraying coolant and stuff. So for that, at pretty much basic CNC, this should be perfect. So anyways, now I guess I'm just gonna mess around with some of these settings and see if I can get a motor moving from the MASSO. So like I mentioned, having a few less options to choose from isn't the only thing that makes this controller really easy to work with. It's also really nicely and clearly laid out, and you can also find really helpful information about pretty much everything about this controller on MASSO's own website, which is a whole lot better than having to look on a lot of forums all over the internet if you want to figure something out. Alright, managed to get some movement. Take a look. So just going in here to the jog screen, pressing one of these buttons makes it move. And then I can adjust the speed over here. That's already moving pretty fast. So all I had to do was go into setup and then choose what axis I wanted to move. Double tap it. So here we have the distance per revolution, which is basically the thread pitch of the ball screw. And then we have the pulses per revolution, which should be similar to what I set up in the servo drive. And then maximum speed, acceleration speed, and the travel limits. So we save it, go to jog, and it works. So with one motor working, I think I should be able to set up all other 3 motors pretty easily. But before I get carried away with that, I think it's first very important I set up the homing switches. And the reason why it's important I set up the homing switches in this state is because, well, the machine doesn't have a home yet, which means it doesn't know where on the table the gantry is, which in turn means it could just run off on that side or on this side and crash into this. And with this powerful servo motor, with the gear reduction on the ball screw, this gantry is super powerful and the crash will cause some serious damage. So in order to prevent all of this, I have to give the gantry and all the other axes a home. And with the home, the machine knows it can't move any farther this way and crash. And then in the MASSO, I can program the distance. I allow it to move in the other way. And that way it also can't crash into that side anymore. And we need to do that for all the axes, and for the y-axis, this direction, I need to do it on both sides, and that way I can also square up the gantry if it isn't perfectly square. Anyways, for the home switches, I have these ones which came with the MASSO kit. They're optical switches, so they should be very reliable and accurate. And to start off, I'm first going to do this axis, so I want to mount it somewhere here. Okay, so I had to do some more tinkering around, but now the homing for this axis works. Double tapping this, and it starts moving towards the switch. Then it hits it and moves back a little bit, and now it's homed. And I can move it away from the home switch, but I can't move it any closer to the home switch. And now I can also set my limit for moving the other way. So that's that homing switch done and working. Now I just got to do the rest of them. Alright, so quite some tinkering with the MASSO later, but I managed to set up all the homing switches and it does work now, so let me show you. So looking at the MASSO, I've set it up, so when you first start it up, it first requests you to do a homing sequence, just so all the axes know where they are in the machine. But right now it's already started and homed, but I can rehome it by double tapping this button right here. And first we'll do the Z axis, moving up, then the X axis, and then the Y, going to the switch, and then moving up it a little bit. And now it's homed, as you can see right here. Everything is at 0, but when I move it, it moves up, so that's good. And also I've installed the pendant. This thing, basically a remote control to move the machine around. So here you can select which axis you want to move, X, Y, Z, and then the speed, and then you can move it by turning this knob. So I'll go to the Y, and then full speed. So with all that done and working pretty good, I think it's finally time to look at mounting the spindle. Alright, so here we have the spindle. Let's take a look. Okay, so here it is, and it is properly heavy, especially on this side, the business end, because in here should be 4 times a ceramic bearing, which are much better than normal steel bearings. They have a longer lifetime, have less play, can run much faster, and have a longer lifetime. And then here in the middle, of course, the motor port, 9 kilowatt or about 12 horsepower, quite a lot. And it is air cooled, so on this side we have the cooling fan. And this thing can run up to a maximum RPM of 24,000. And I don't think I will be needing the 9 kilowatts of power anytime soon, but it's nice to have, and also it means it has more torque at lower speeds. And that'll come in really handy when I'm, for instance, milling steel or drilling something. And right here we have 2 pneumatic connections, which are needed for the party piece of this spindle. And that is its ATC capability. So ATC stands for automatic tool changer, and that means that if I supply air to one of these ports, basically the tool can fall out and I can easily insert a new one. Or it can even do that itself, fully automatic, which I plan to set up later in this video. So for the automatic tool changer to work, we need this, which is an ISO 30 tool holder, and as the name suggests, this holds the tool, and then this can easily clamp and unclamp into the hole of the spindle. And you can mount pretty much any tool in these tool holders, and I'll show you how to do that later. But first I want to mount the spindle, and as you can see there's actually no mounting holes on there. But to mount it there's a T-slot on the back, and in there I can slide a bolt and then put a knot on there. And also I've been checking the run out on the inside of the cone of the tool holder on the spindle, and I can safely say there is simply no run out to be measured whatsoever. And that's really good news, because if there's run out, that means a lot of vibrations, especially at 24,000 RPM. So that's pretty much it for the spindle. Now let's mount it on the Z-axis, wire it, and see if it actually works. So now to build the air system, first up we have the pressure regulator and water separator. Then this air distribution block. And I'm using all these push-in tubing connectors, which are really quick. And then some air solenoids, which I can connect to the MASSO to allow it to control the airflow, which is needed to perform the tool change. And connecting everything with some of this 8mm tubing. And then we can plug in the air pressure supply here. And I'm also adding this aero gun, which will be useful for blowing away chips. And after hooking everything up to the spindle, we can see if it works. Okay, the tool is in there and clamped, the spindle is working, and of course the entire machine is working. So I think it's finally time to do that very first test cut. Pretty excited. Yes, welcome to the workshop office. And I've been doing some CAD design, and this is the first part we're gonna make on this CNC. Yep, so here it is, quite literally a test cut. And I've also already been doing all the cam for this, so basically how it's gonna cut, at which speed and which depth. And here you can see the simulation for that. So it's just gonna cut away all the letters and not the contour. Pretty simple, but you know, it's a first test. And now I just hit post-process and it will make a G-code for me. And now I just open up the MASSO link software on my PC, drag the file into there and send it to the controller. So that's that, it's on the controller now. All that's left to do is cut it. And let's just say I'm both nervous and excited in equal parts. Okay, so definitely not the nicest result, but that's mostly because I'm using a spiraling upcut bit, which causes all this tear out. But for the rest of it, it does work. I'm super happy with this. Let's cut another one. Alright, second one turned out a whole lot nicer than the first one. Nice, sharp, clean edges this time. So, not perfect yet, but very pleased with it, not bad. For the first time. And don't forget the gantry at the moment is only driven on this side, no motor on that side yet. So next thing I want to make is the automatic tool changer. So basically a rack into which I can mount all of these tool holders, and then the machine itself can drop tools and pick up new tools from that rack. And what I could do is just mount the rack somewhere on the table and let the machine go there and pick up the tools that way. But the problem with that, of course, is I lose quite a lot of precious machining area, so I don't want that. So what I'm going to do is make a rack which can go in the back there, where the machine can't come anyway, so there's always space there. And then when it wants to do a tool change, I'll have it slide out using pneumatic cylinders, and then it can pick and place the tools and then slide back in again. And also I want to make a cover which will go over the rack and goes up and down to stop the tools from getting covered in sawdust. So these holes need to be tapped, and to tap a hole straight out of the plasma table is not really a good idea. So what I do instead is have the plasma pack pierce a small hole for me in the right location, and then I can drill out that hole to the right size and tap it. Okay, so as you've seen, the tool changer moves under its own power. Pretty nice and smooth. So that's all of this pretty much done for now, and now I have to make the actual rack which will hold the tools. So to make it, I've got this piece of hardwood which is laminated and therefore should be pretty nice and stable and should work just fine. I'd love to make it out of aluminum, but that would be just too expensive, and also for being a version 1, I'm not sure if it's going to work yet. I'll just try this one first. So this piece is going to have to be machined on this CNC. So first cutting all the holes for the tools to drop in, then milling the outside contour, and finally engraving the numbers. Now obviously the CNC at the moment is far from finished, but I think it should be able to make this. And of course there isn't even a machine bed on there yet, so I'm gonna have to get a bit creative on how to mount this on here flat. So what I'm gonna do is first mount a piece of wood on here with some clamps and then flatten it using the CNC and a big flattening bit. And then I can screw my workpiece piece of wood to that and machine it. And I've also added this ball screw and a motor and a ball nut and stuff. So the gantry is now driven from both sides, which should make it much more rigid. So I'm pretty excited to try this machine out and make an actual part on it. So let's give it a go. Okay, so first ever real part made on the CNC. Apart from the tear out on the front here, it turned out pretty nice. The tool holders fit in there as well. Pretty much no play, but they still come out really easily. And for the engraving of the numbers, it also turned out pretty good. Except that I should have probably done a tool pad starting from the outside and moving in, instead of what I had now, moving from the inside out. Because cutting from the inside out meant it didn't really cut the tape all that sharply, and rather pushed it up a little bit. And that means the paint job of the numbers isn't as sharp as it could be. But it doesn't matter, it will work just fine. I'll probably end up making another one day if I crash into this or something. So anyways, let's get it mounted. Okay, so that's the tool holder rack all finished, and I've hooked up the pneumatics and now it works as well. So when I push this, it moves out, and then when I push it again, it moves in again. Very nice. So now to make the plexiglass cover. Okay, the cover is on there and working pretty smoothly. And in the meantime, I've been doing some fiddling around with the MASSO controller. And guess what? It's only working. Okay, you have to admit, this is pretty cool. I love the way how it goes back and covers itself up again. I love the way how it picks it up. It just works amazingly. First try, so super happy with this. And this automatic tool changer really converts this machine into a much more capable machine. It can now run programs of hours long without me having to even touch it. So it's gonna be amazing. So yeah, I've just been looking forward to seeing it work and to actually have it working. I'm just so happy. But anyways, I think this video is already going pretty long, but I still want to do one more thing, which is finish the flood coolant system. So basically seal the entire bed with caulk and then make the coolant reservoir, put the coolant pump in there, hook up the coolant line, which will go to there. And then once that's on there and working, we are gonna try cutting some steel. Yes, let's go. Okay, the coolant system is working. There's a lot of coolant coming out of there under high pressure, which is good. But the problem now is metal chips will flow down and fall back into the coolant reservoir and clog up the entire system, so we don't want that. So I'm gonna make a filter, and for that I need a metal sheet with a lot of holes drilled into it. So now let's use this new CNC with coolant and a drill in there to drill the holes. Okay, so that's it for this video. Homemade CNC machine, part 4. And well, what can I say? We basically have a working CNC machine now. And to have this machine at my disposal is actually kind of mind-blowing. And I love using it so far. Of course, thanks again to MASSO for sending me the controller. It's great, I love it, I really recommend it if you want to build a CNC machine yourself. Also the tool changer works great, I love how the cover flips up and the tools come out. Also the coolant system is working, but as you can see, it makes quite a big mess. So that's going to be addressed in the next video, which is making a big enclosure for this thing. Basically with a big hood which you can open and a door here on the front. Plexiglass windows, all kinds of stuff. Then use the machine itself to flatten these square tubes, so we have a nice flat surface to mount our machine bed to, which we're going to make out of really thick strips of metal with a slot in between there, so I can slide a bolt in between the slot and tighten things all over the bed. Then time for the really big job. Take everything apart, paint everything, then reassemble it properly with Loctite between all the bolts. Then relocate the electrical control box to go under there and tidy everything up. And I'll probably end up making a big drawer under here as well to store all my tooling. And after that it's finally finished and I can start making some real cool stuff with it. So thanks for watching. See you in the next part.